In this problem, we are given the current in a 2 millihenry inductor is I is equal to 50 times T e negative 10t. And this is in amps for t greater than or equal to 0. We need to find the voltage across this inductor. And if we looked in the notes linked below in the description in section 6.1, the inductor, we're going to see that we have a formula that looks like this. So we're basically taking our L and we're multiplying it by the derivative of our I. So we can plug in our known values. We can say that our V of L is equal to 2. And for the milli, I'm just going to substitute that with a 10 to the negative cubed. That way it's just in henries. Now I'm going to multiply this by the derivative of our current. I'm going to take out the constant 50, and then I'm going to do the derivation where I have f prime g plus g prime f. We know that our t is equal to 0, so that's what we will be plugging in. Before we do that though, I'm going to rewrite our equation in a little bit more simplified form. After we do that, we are going to get this. So this is our voltage formula, and now we can just plug 0 into here. If we plug 0 into here for this e, we are going to get 1 because e raised, or anything raised to a 0th power, is just 1. This right here is just going to be 1 as well. So all we have left is 2 times 10 to the negative 3 times 50. Well, if we do this, we are going to get 50 times 2 is 100. And then we could move the decimal 3 places to the left. So we're going to get that our V of L is equal to 0.1 volts. However, we want this in millivolts, so our V of L is equal to 100 millivolts. And that is the answer for this first part. Next, we're asked to find the power absorbed or delivered by the inductor at t is equal to 50 milliseconds. We're going to do the same thing for C, just at 200 milliseconds. Now, there is a power formula, and it's derived from voltage times current. However, in our equation right now, we already found voltage. So we should just use this and multiply it by our current to get our power formula instead of rederiving everything. Because in using the power formula that's derived, we have to take the integral, and it would be kind of messy for this problem. So we're just going to say that our P of L is equal to the voltage of L times the current of L, and this is going to be our power equation. Now we can plug in our T. We're going to look at our T, and we're going to convert this into seconds instead of milliseconds. So we can say that our T is equal to 50 times 10 to the negative 3 seconds. And the reason why we have to convert this and not leave it in milli is because this number would be originally so small that the calculator would round it to 0. So for this t, and this t, we're going to plug into our calculator 50 times 10 to the negative 3. We're also going to be plugging this in here because this is also a t. If we do this, we're going to get that our P of L is equal to 0.4598. And this is in watts. We want this in milliwatts, so we're going to have to multiply this by 1 milli over 10 to the negative cubed. And this is basically being multiplied by 10 cubed. So we're going to move this 3 decimal places over, and we're going to see that our P of L is going to be equal to 459 milliwatts. That is the answer for our second part. For part B. Now for part C, we are going to be plugging in 200 milliseconds. So we can use the same exact power formula and replace all of the 50 times 10 to the negative cubed with 200 times 10 to the negative cubed. If we carefully plug this into a calculator, we're going to get that our power is equal to negative 0.183 watts. We want this in milliwatts, so we're multiplying it by 1 milli over 10 to the negative cubed, just like last time, and we're going to say that our power L is equal to a negative, if we move it over 3 times, 1, 2, 3, 18.3 milliwatts. And those are the answers and how to do this problem. If you want a more introduction to circuit analysis, there's a playlist as well as notes in the description. If you have any comments about the material covered, you can leave them below and we will answer them as well.